You ever wished you could just tell your PLC to skip a few steps, just jump right to the good stuff? Well, in the world of PLCs, that's not just wishful thinking, it's an actual command. So today we're going to demystify two of the most powerful and honestly misunderstood instructions in RSLogix 5000, jump and label. Let's dive in.
Okay, so think about this. Remember those Choose Your Own Adventure books? You don't read them page by page, do you? Nah, you jump to the page that matters based on the choices you make. So what if your PLC program could do the exact same thing? What if you could literally tell it to break its normal routine and just skip huge chunks of code whenever you want it?
You see, a PLC is usually super methodical. It reads its ladder logic just like a book, one line or rung at a time, from the top all the way to the bottom, over and over again. And that predictability, that's the bedrock of automation. It's what makes it so reliable. But today we're looking at a tool that's designed to intentionally and very deliberately break that sequence.
All right, so here's our game plan. We're going to start by talking about what it even means to break that normal sequence. Then we'll get properly introduced to the JMP and LBL pair and see how they work in the real world. From there, we'll dig into the good, the bad, and the ugly, the power and the pitfalls. And finally, we'll wrap up by looking at some smarter, more modern ways to get the job done.
First up, breaking the sequence. How do we introduce non-sequential program control? So yeah, how do we get this non-sequential control into a PLC's very, very sequential world? Well, the answer lies in this really special partnership, a command and its destination.
It's kind of like giving directions, right? The jump instruction, that's JMP, it's the command. It's you saying, hey, go to the corner of main and first. And the label, the LBL instruction, that's the actual signpost on the corner that says, you're here, main and first. So one is the action, the other is the destination. And here's the kicker. One is completely useless without the other. They have to work together.
So let's meet this JMP/LBL pair and see how these two instructions work together. To really get it, we've got to look at each one on its own first.
First up, we've got the JMP instruction. And right off the bat, here's a super important detail. It's an output instruction. What does that mean? It means it only does its thing when the conditions on its rung are true. And when that happens, it's basically a giant detour sign for the PLC. It tells the processor, hey, stop what you're doing, ignore all the code coming up, and jump straight to the specific label I'm telling you about.
And the label, the LBL instruction? Well, it's just a marker. That's it. It's a destination. It's a non-executable instruction, which is a fancy way of saying it doesn't actually do anything. Its one and only job is to be the target, the landing pad for a jump instruction. Oh, and it's got one really strict rule. It has to be the very first thing on its line of code. No exceptions.
All right, let's get into the jump in action. Time to visualize how this actually changes the program flow. We've met the players, now let's see the game.
It's really just a simple four-step dance. So, step 1. The PLC is just doing its thing, scanning normally, top to bottom. Step 2, it hits a JMP instruction, and hey, the conditions are met, the rung is true. Step 3, bam! The processor instantly skips over all the logic between that jump and its target. Just gone. And step 4, it finds the matching label and picks up the normal scan right from there. See? It really is just like a choose-your-own adventure for your code.
But, and this is a huge but, here's where things get really tricky and honestly kind of dangerous. What do you think happens to all the outputs in that code you just skipped over? The PLC doesn't turn them off. It doesn't even look at them. They are just frozen, stuck in whatever state they were in the last time that code was actually scanned. And let me tell you, this is a massive, massive source of confusion and can be a total nightmare to troubleshoot if you're not ready for it.
Okay, time to talk about power and pitfalls, the double-edged sword of program control. That last point brings us right to the heart of the matter, really. The JMP instruction is absolutely a double-edged sword. It gives you some real power, but man, it is loaded with potential pitfalls.
So on the one hand, yeah, this is a powerful tool, no doubt. Let's say you need to bypass a whole section of code for a piece of equipment that's down for maintenance. A JMP can do that. Boom, saves your precious scan time. You can even get clever and jump backward to a label that came before it, creating a loop that forces a chunk of code to run over and over in just one scan. But, and this is a really big but, this tool can easily create some serious problems. JMP is notorious, absolutely notorious, for creating what we all call Spaghetti code. You know what I mean. It's messy, it's impossible to follow, a total pain to troubleshoot, and in some cases, it can be downright dangerous to your machine and your process. So let's get specific about the dangers of JMP and LBL. First, infinite loops. A backward jump without a solid way to get out of it can and will fault your PLC. Game over. Second, it makes troubleshooting a nightmare. This nonlinear flow is what creates that spaghetti code we talked about. Third, you get those unpredictable outputs, the ones that are just stuck in their last state, which can cause all sorts of confusion. And finally, it just makes the code super hard to read. Think about the next person who has to look at it. Or, think about yourself 6 months from now trying to figure out what you were thinking.
So, if the JMP is this risky, there's got to be a better way, right? Of course there is. Let's talk about some smarter program control, some modern alternatives, and best practices.
Okay, a much better alternative is the JSR. For most situations, the jump to subroutine or JSR is just way better. Instead of just hopping around wildly in the same routine, a JSR calls a totally separate, self-contained routine to do a specific job. And here's the magic part. When that subroutine is finished, the program comes back. It returns to the exact spot where it left off. It's organized, it's reusable, and it's just so much cleaner to read.
Now, let's clear up another common point of confusion. JMP versus MCR, the master control relay. On the surface, they seem kind of similar, right? They both can basically deactivate a zone of code. But you have to remember that critical detail about the outputs. A JMP, it leaves the outputs in the skipped zone in their last state, whatever that was. An MCR, on the other hand, actively forces all the non-retentive outputs inside its zone to the off state. Getting this difference is absolutely crucial for safety and for having a machine that behaves predictably.
All right, let's bring it all home with some best practices. 4 simple rules. Number 1, use JMPs sparingly. Seriously, think of it as a last resort, not your go-to move. Number 2, if you absolutely have to use one, document the heck out of it. Leave comments explaining why it's there. Your future self will thank you. 3, avoid backwards jumps. Just don't do it. The risk of creating an infinite loop is just too high. And finally, number 4, always ask yourself, could I do this better with a JSR? And you know what? The answer is almost always going to be yes. So when it comes down to it, the JMP instruction really is the ultimate shortcut in ladder logic. But, as we've seen today, and programming, just like in life, is a shortcut always the best path? Something to think about. Thanks for tuning in.